Dear students, we will discuss the concept of serial communication and related programs. So, serial communication generally it referred to the process of transmitting a one bit at a time. Okay, the process of transmitting a data one bit at a time. Okay, in 8051 you have built-in UART for serial communication. It is universal asynchronous receiver transmitter. So here you can see this is a wiring of 2 UART. One thing here you want to observe here is the receiver of the UART 1 will be connected to the transmitter of UART 2. Similarly, the transmitter of UART 1 is connected to the receiver of UART 2. So this is a connection rule you need to follow for serial communication. The next important definition is baud rate. So it tells you speed at which the data is transmitted. It is measured in bits per second. See, you are using asynchronous communication to indicate that you have a start bit and stop bit. Okay, let me say you have a data 41. Okay, so I want to write the equivalent, it's a hexadecimal. Okay, I want to write in terms of bit. Okay, that means 0 1 0 0 0 0 0 1. That means 8421 8421. Okay, so this is a data I need to send. So this is your LSB, this is your MSB. So here you have a start bit. The start bit always it will be 0. Here you have a stop bit. This will be always 1. That means 1 0 1 0 0 0 0 0 then 1. Then again you have a, this is a start bit, right? This is a start bit. Always remember start bit will be always 0. Then your data 1 0 0 0 0 0 1 0. This is a stop bit. So this is a very important. Okay, so while you are doing the asynchronous communication, you have a start bit, stop bit. Start bit will be 0, stop bit will be 1. Okay, now I will just give the idea of what are the important register you need to know to write the program. Okay, two important register in serial communication is SBUF and SCON. What is SBUF? SBUF is your 8, it's a register. Okay, it can store 8-bit data. Okay, it can store 8-bit data. So what purpose we are using this SBUF? It is used for sending and receiving data. If you want to send, first data will be written to the SBUF. From there only it will transmit it serially. Similarly, if you want to receive the data, first it will serially received in SBUF. From SBUF, the data will be transmitted to accumulator. From the accumulator, it will go into the ports. Clear? So this is a logic. Okay, it's a register. It can store the 8-bit data. The next important register is SCON. SCON is a serial control register. It is used to configure the mode of serial communication, whether you are using the mode 0 or mode 1 or mode 2 or mode 3. Okay, in that specifically you can say whether you are using 8-bit UART or 9-bit UART. Okay, that you can be configured through this SCON register. Another important two interrupts are TI and RI, that is transmit interrupt, receive interrupt. Okay, while data is transmitting serially, this TI will be 0. Okay, from the SBUF, see, data will be written to the SBUF. From the SBUF, the data will be transmitted serially, right? So while it is transmitting, the flag will set the status of 0. After transmitting the complete 8 bit, right? So it will, the flag will change to 1. Okay, that will be informed to the controller, so that the controller will understand the 8 bit data has been sent successfully. Similarly, RI, while the data has been serially received in the SBUF, all complete byte has been received, the flag will change from 0 to 1. That means all 8 bit, that is complete byte, has been received. Okay, these are the important logic you need to know before writing the program. I'll just give the idea overall process. Okay, suppose I have a data A is a character. Okay, the equivalent ASCII code is 41. Okay, so generally this will be in accumulator, it will be stored in accumulator. Okay, so what it will do, the data will be returned to the SBUF. Okay, the data will be returned to the SBUF. Okay, then you have a pin, it is a TXD pin 3.0. so here you have a logic of UART. So with the UART, okay, so data will send serially. Okay, so that means you have a logic of, you have a data 41, right? So that is the equivalent ASCII value of this character A. That means 0 1 0 0 0 0 0 1. You have a start bit, you have a stop bit. While it's sending a data, that is D0 D1 D1, during this condition your TI will be 0. Once it recognizes this stop bit, this TI will change to 1. It will inform to this controller. That means it will understand that all data has been transmitted successfully. Similarly, while data has been receiving, okay, serially it received in the port 3.1, that is RXT. Okay, through you are receiving the data serially and it will store in SBUF. Okay, so once you receive the complete data, complete byte, this will, the flag will rise to 1. That means, what is the understanding is, the complete byte has been received. Once it received in SBUF, it will go to accumulator. From the accumulator it will going to port. Okay, this is a logic. Okay, you need to write the program. So I'll just give the algorithm. Okay, I'll just do quick review. Okay, so anyway we are seeing the program. Okay, the first what we need to do is, I need to set the timer, in the timer which mode you are going to use. So that's why I use the tmod register. Okay, so you know you are using mod 2, so that is a 8-bit auto reload. Okay, so that means you have a th1 value, th1 is loaded, right, with the, based on your requirement of the baud rate, that value will be loaded in th1. Okay, accordingly the serial data transfer has been accomplished. Okay, then you want to load the scon. Scon is a serial control register. Okay, so here it is given 50. 50 means what? So 0 1 0 0 0 0 0 0, right? So that is equivalent to 0 1 0. So here it is 8 4 2 1, 8 4 2 1. So this is 5, this is 0. That means I want to use mode 1, right? I want to use mode 1, and you want to enable this REN. That is, you are enabling the reception. Okay, so this is a third step. In the fourth step, you want to enable the TR bit. So once you enable the TR bit, the timer will start the process. Okay, then the character byte will be transferred serially, whatever you written in the SBUF, right? So during that transferring the data, while transferring the data, every time it will check, every time it will polling the process. That means jump if it is not set. I said clearly, right? So while it transferring the data, the flag will be 0. While it recognizes the stop bit, this TI will become 1. So condition failed, so it comes out, then it will clear the, again it will clear the TI, right? Then it will start to transfer the next byte. So it will go to the step 5 and it will do the process again. Okay, this is a algorithm. For that we need to write the program. This is a basic algorithm. Okay, okay, so this is the first program we are going to discuss now. So write a 8051 assembly language program to transfer the letter A serially at baud rate of 4800 continuously. Okay, so first instruction org000h. So it tells the assembler to start the program at the memory location of 00h. This is the first instruction on it. Then I am saying to set the baud rate. First I want to start the timer, right? So I want to fix that which timer, which mode you want to fix. That we can do with the T mode register. Okay, that is 20. That means you are working a timer 1 and mode 2 logic, right? That means 8421, right? That means 0 0 1 0 0 0 0. This equivalent is 2, this equivalent is 0. That means you want to work in mode 2. This is 10 is equivalent to mode 2, right? So which timer? This is the bit, this 4 bit is for configuring the timer 0, this 4 bit for configuring the timer 1. Okay, that means I am going to use timer 1 and mode 2 8-bit auto reload, right? So it was given 4800 baud rate. Okay, to get 4800 baud rate, I want to fix -6. Okay, so the equivalent hexadecimal value is FA. That means FA, 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 FB, FC, FT, FE, FF. You have a 6 count, right? So again it will reload. Okay, that is a logic. So the -6 is loaded. -6 equivalent is FA will be loaded in the TH1. So I hope you understand, right? The third instruction, what you are doing is this: set the high byte of TH2 -6, that is FAH. That is the third instruction. Okay, so now you want to set the SCON, right? What is SCON? SCON is a serial control register. So I'm sending 50. So if I'm sending 50 immediate value to SCON, that means what is the understanding is 0 1 0 1 0 0 0 0. This equivalent is 5, this equivalent is 0. So if I'm sending 5 0, it means I want to work in like a 8 bit and one stop bit, and your REN is enabled. So you can see here 0 1 0 1 0 0 0. Okay, this, you know, these two bits for identifying which mode you want to use. That means you want to work mode 1. Okay, you're going to use the mode 1, right? And you are using REN, you are enabling. Okay, so even you are working in the transmitter program, you want to enable, you can enable this REN. So generally, like a if any data comes from outside, not intentionally, any data, if it comes, you can receive those value also. That's why in all the program, while you're writing a transmitting and receiving program, both the case you can enable this REN. Okay, so that's why it is written move SCON 50H. Okay, then you want to start the timer. By setting TR1. Okay, you are start the timer by setting TR1. Once you set, your timer will start. That means your value will be written in SBUF, right? Your A will be stored in SBUF. Okay, once value is written to the SBUF will start to transmit the data to send serially through TXD pin. Okay, what is the equivalent of A? 41. So the ASCII value of A is 41. Okay, already I said it will follow the logic of start bit and stop bit. Okay, so first it will send the start bit, always start it will be 0, then it will send the 41, that is the equivalent value of A, that is the character I want to send is A, that equivalent ASCII code is 41. That means 0 1 0 0, then 0 0 0 1, and the last stop bit will be always 1. So this is a stop bit and this is a stop. See, you can see here, jump if bit is not set. See, while you are sending this D0 to D7, the flag TA will be 0. That means condition is true. Jump if bit is not set. While it's sending a data, your TA is 0. The condition is true. That means it will be keep on looking for last bit. Once it find the last bit, so what happened? Your condition fail. It will comes out from this line and it will clear the TA. Okay, it will clear the TA. It clear the TA flag for the next character to transmit. So again it will go to the short jump to again it will start to write the data to SBUF. From SBUF you will send the data serially through TXD pin. Okay, this is a continuous process will happen while running this program.